Hello, everyone, and welcome to another episode of Trying to Solve Advent of Code in Rust and Trying to Learn Rust in Between. My name is Luciano, and we also have
Roberto. Hello.
So let me introduce you really quick on what are we going to try to do today. We are streaming Advent of Code. If you never did, Advent of Code is basically a coding challenge that happens every year, more or less during the Christmas period. It's actually from the 1st of December to the 24th, and you have 25 coding challenges. So we are working towards the last year ones, 2021, and you can find all the description and exercises online at adventofcode.com. We also have a repository where we commit all our solutions in Rust. Everything is well accepted. If you want to contribute, if you want to give a suggestion, improve our code, add benchmarks, make things faster, everything is extremely welcome. As we said, we are trying to learn Rust, so we are definitely not going to be the most expert or idiomatic in our code. So feel free to contribute, and even if you are in the chat, definitely feel free to give us advices, ask us questions, and let's try to solve these problems together. We also publish all the recordings on YouTube. There is a link for that as well. It's youtube.com/Loige. And yeah, that's pretty much it for the intro. So last time, what we were doing is basically working on exercise 19 of 2021, which is probably one of the most challenging we have seen so far, and is about finding basically intersection of points in a 3D space and trying to figure out position of objects based on all of that. And we did a little bit of progress last time. We saw a solution written in Python by Roberto. So we do have a working solution, but not in Rust. So we are going to try to use a little bit of our solution from Python and try to rewrite all of that in Rust and then do testing, performance, maybe figure out how we can improve different things.
Refactor improvement once we have green tests.
Exactly. So what do? Do we just share the screen?
Yeah, give me a moment. Yes, the screen is on. I can see your VS Code.
I'm gonna go very quickly on what we have so far, and then we are gonna see some helpers that we had in the Python code and try to add those as well. So what we did last time was basically just parsing the input. The input looks something like this. So we have scanners and beacons, and you can imagine that we are trying to map like a 3D space in the oceans using these concepts, scanners and beacons. Basically, a scanner is just a fixed point somewhere in the 3D space, and it can monitor a bunch of beacons. So it can kind of detect that there are certain beacons relative to its position. So what you see here is basically a list of the current starting state, where basically you have a section for every scanner, for instance, scanner 0, and a bunch of coordinates. Then the same for scanner 1, and we have a bunch of scanners. I think there are like 50 or something like that. Or
33?
30.
31?
Or 31, yeah. Start from 0, right? 31. So, and every line is basically a coordinate in this 3D space, and that represents a beacon. This position is relative to the position of the scanner, which is also unknown. So we could assume that the first scanner position is 0, 0, 0, and then everything else is something that we have to figure out in relationship to that initial scanner. So basically what we are trying to do is, for every scanner, we have coordinates. We are trying to figure out which coordinates overlap across different scanners so that we can try to position each scanner in relationship to some other scanner. And eventually we plan to be able to map the entire space and figure out what are the relative positioning of all these objects in the 3D space.
And all the final position must be relative to scanner 0 that we assume is in a 0, 0, 0, so the origin of the 3D space, and is flipped and rotated in the right way.
Perfect. Okay, so what we did last time was pretty much just parsing the input. So we created a bunch of structs. So we have this concept of a scanner that has its own position. We also have the concept of a point 3D, which is just a tuple with 3 integers. And then every scanner has an array of beacons, which every beacon is simply a point 3D because a beacon doesn't have any other property except its own position. So what we did, we implemented from string for point 3D, so we can easily parse every single line of the input here into a point 3D. Then we also have a parse input. So this helper function basically takes the entire input file and gives us an array, so a vector of scanners. And this is literally everything we did last time. And the only thing we are doing here is just literally parsing the input and printing the scanners that we had so far. And we were actually eyeballing the results, and it seemed that everything was parsed correctly. Now, if we look at our Python code, which I have copied here, there are a bunch of helper functions that it would be convenient to start implementing them in Rust, because these are the ones we're going to use for our solution. And the first problem is that every scanner is actually not just unknown in its position in the space, but also in its own rotation on all the different axes. So we need to also keep into account that for every scanner, we need to test basically every possible rotation in the 3D space, of course, angles of 90 degrees. And we need to check the overlapping between points in all the possible rotation to also be able to understand which one is the correct relative rotation of different scanners. Am I saying that correctly, Roberto?
Yeah, because they can be rotated and flipped, and yes, it's a mess. It's a lot of possible variation.
So Roberto actually did a very good job of writing this Python function where, given a scanner, it's like a generator function, so it yields all the possible rotations of that scanner. And we can build something similar. Maybe the simplest we can do is just return a vector of all the possible scanners rotated in all the possible directions. Or if we have time to be fancy, we can even do an iterator or something like that. But yeah, basically, this is the first thing that we should be implementing. So I'm going to copy all of this because, I mean, there is already a lot of brain power that was spent here to just make sure that all these tuples are done correctly. So I'm just going to assume that all of that is correct because in Python we had testing, we had correct solutions. So we assume that all of that was correct. So I
passed the exercise 19 in December last year, so it's working.
Exactly. So let's do that in the scanner class, maybe. In the scanner struct, we can say implement scanner, and then we can say fn rotations, and this one returns a new vec of scanners.
Yes, because scanners contains a vector of 3D points. Cool, okay.
Cool, so now if I'm gonna just copy paste the Python code as a reference, let's try to figure out what we need to do.
The first instruction was that zip is basically splitting the vector of 3D points of the scanner in a vector with all the x, a vector with all the y, and a vector with all the z, because we don't know how it is rotated, so we will use that vector. The vector in x could be in reality the vector for y once the scanner is rotated in the correct direction, and the vector for z can be the new x and stuff like that. So I had to split this vector of 3D points in free vector with all the x, all the y, and all the z, and that is one line in Python.
Okay.
So now we can declare free vectors.
So for you, scanner was what, the array of points?
Yeah, is what we call beacons here.
Okay, fair enough. So okay, let me think how we can do that in. I mean, we could do a map, right?
We could do a map or a for each on top of the vector. We need to come out. We need to come out from this with three vectors: one called x, one y, and one called z. If it makes sense, I don't know if it makes sense.
I'm gonna do first. Let mute scanners. This is what we want to return at the end.
Okay.
Right. Another thing that I wanted to ask you, because we declared the position as an optional, right? When we parse something, we don't have the position, then we're going to infer it. For the first one, we said 0, 0, 0. For the other ones, we need to figure it out.
Yeah.
Is it relevant for this function to have our current position or not?
No.
Okay, because we are going to use the position of the points as a reference to figure out the current scanner.
We don't know. We don't know which one of these generated rotation will be the right one, and that is in another function. This function is just providing you all the possible rotation. Then there will be another function that will tell you the right rotation is this one because at least 12 points overlap with the scanner that we already know, and we start knowing only scanner 0. It is the first scanner. It is the only one that we know at the start.
Makes sense. So X is basically scanners.beacon.either.map.
Okay.
And then we want to have a point and take the 0.
That is the first value. Okay, yes.
And then collect. Let's see if that works. My laptop is extremely slow, so please bear with it.
And please send €5 for your laptop for Luciano.
And also scanner. I keep doing this mistake. Cool. Is it active? No, it's not.
Because we are returning nothing.
No, we are returning below the comments. I already added that. No field called beacons.
And because you have to do self beacons. And
yes.
Probably you also have to take self as a parameter in the function.
And you need to take self not mutable because we're not going to change anything.
We are creating new object. We are not mutating it now. We will have to mutate the scanners later, or replace and discard. Well, we'll see. Not now. Now let's focus on what we have to do.
Okay, here we didn't like something that I did. Scanners. Why I didn't like it?
Show me again. Scanners is a vector of unknown.
Oh, yeah, no, sorry.
Because we never added anything to the...
Yeah. Okay, that's now correct. Cool. So we can do the same for Y and Z.
Yeah, with the P1, P2.
Y. Okay, so at this point we have all the coordinates for all the x's, all the coordinates for all the y's, all the coordinates for the z's in individual vectors. So now here what you're doing, you are basically...
Okay, the first line 21, is yielding basically the same scanner that the scanner like it is. So in reality, no change to the scanner structure. I'm yielding exactly what we got in input.
Okay, one thing I want to do is to make this clone, because we need to clone like crazy, I think.
Okay, the first row can be, at this point, the first stuff that we have to add to scanners, to the vector scanners, is a copy of self beacons. Or a copy, no, it's not, we have to return scanners, okay. A clone of self is the first element that goes into scanners.
Scanners.push is basically a scanner. Sorry,
it can be self-clone, it works.
I think it should work now that I added the derive of clone.
Okay, and this cover line that now is line 23.
So this one is done.
That one is done. Now, next step, we have to switch Z with Y. And we have to create at this point a list of 3D points taking the vector of X as X, the vector called Z as Y, and the vector called Y as Z.
So we are swapping Y and Z.
Yeah. And we have to create a new scanner and push that scanner in the scanners vector. Okay, so we have to create a new vector of point 3D that will be the beacons.
I'm wondering if it makes sense to have like an helper function.
Oh, probably yes.
You just pass these 3 values and it builds.
Yeah, in the right order. Let's create it, because in Python this helper function is zip. There is zip also in Rust, right?
There is. I think so. Yeah.
This is a static function. I don't think it's meant to be a function.
I was thinking new
self.
from row coordinates or something like that.
Yeah, but the parameters are X, Y, and Z. Self is not needed here.
Yes, exactly. Yeah. So here we have X, which is a vec of I32.
But can you declare? This is basically a static function if this was another language.
And this is going to be a static function.
Yeah. Do we also have statics in Rust?
Good question. There is static.
Or we can take it out of the impl section and we are done. But if you want to keep them together for semantic reasons.
Yeah, that's fair enough. Here I'm doing kind of a bit of a package. So yeah, fair enough.
And Z, not X again. Yeah.
And this one returns a new scanner, right?
Or do we want to return a scanner or a vector of point 3D that is a beacon? No, a scanner is easier.
I think it's going to be easier. So let's move this one. And let's just say new scanner. Well, let's just say scanner
from row coordinate. Cool. Okay.
And basically what this one needs to do is...
we can create let mutable beacons vector of 3D points. Point 3D, sorry. I think I can hear the fan of your laptop.
Going like crazy insane, yeah.
Yeah, exactly.
And then what we want to do is basically we need to do like a zip, right?
Yeah, because X, Y, and Z are the same length. And we have to zip them together. And for X0, Y0, and Z0 becomes the element 0 of beacons. And so on for all the length of our... So it's a zip.
So can we do x.ether.zip? And then we need to do y.either.
Then we have to zip again.
Can
You
you
zip
add
a zip.
more? And yeah, I'm trying to figure out what if you need to do zip or if you can pass multiple arguments there.
No, it say 2 iterators. So I think you have to zip.
Okay. Z.either.
Okay, at this point, what this will give? We
This
can
will
map on
need
top
to
of this.
collect or map. Yeah.
Map because we have to create a pointer to the object.
In map, we have X, Y, and Z. And we need to create point 3D of, oh my God, that is super slow. Right, and then collect, and all of that will be, this will be our beacons, basically.
Yeah.
Let's see if it's happy with all of
So
that.
it's not even mutable because it's created on the fly.
It doesn't like map. Why is that? Closure is expected to take a 2 single tuple arguments, but takes 3 distinct arguments.
Try to put round brackets around Y and Z in the declaration. Yeah. Not Y and Z, not X and Y. Yeah, around the.
Oh, you think that they're nested?
Yeah, I have this fear. So they are somehow nested.
Yes, that's super annoying.
Or
is there like a flat?
Ah no, okay, what's happening? Still complaining? Ah, it is on the first 2, the round brackets. Sorry, X and Y in round brackets. Yeah, I'm guessing. Sorry. Try-driven development.
Oh, yeah. Okay, fair enough.
And
it
the mutable
makes sense, but it's still ugly. It takes 2 distinct arguments.
Put again round brackets before the first round brackets and after Z. Oh my God. Can it decompose all of this?
Okay, WGAF is suggesting us something in the chat. I don't know, Roberto, if you can highlight that.
Yeah. Is no, I think we are right now.
Why doesn't like that now, though? Oh, because
it's a reference.
So we need to put asterisks everywhere and clone. Like
well,
in this case, it's copy.
It's an integer, so who cares?
Thank you, WGAF. Super awesome. Please keep the suggestions coming.
Yeah, thank you.
Okay, so here we have beacons. So at this point, we can return.
That you can remove the mutable in line 10 because we are not going to mutate these beacons.
We can return a scanner where the position is
no,
right?
No. Yeah, for now is unknown.
And beacons is beacons.
Yes.
Cool.
And now
I still don't like this thing. I will check later if there is a
we check later if there is a way to to zip more than 2 together. So zip 3.
Oh, Tommaso is here as well. Hello, Tommaso.
Hello.
Cool.
So now we have this function. Let's use it.
So now we have this function. Pretty much we need to use basically everything you have here, right?
Yeah. Except that they already done one.
Yeah. So I'm going to copy all of this and try some crazy.
Multicursor.
Multicursor, exactly.
This is scanner.push of that function. That
I already see issues with references. Let's see what happens. So scanner.push.
Scanners.
Close enough. Push, and then we want to call the function scanner from row coordinate.
Now you.
Ooh, it auto-completes like that. That's it. Now I anticipate. Oh no, too many parentheses. I anticipate problems with references because every time we pass X, Y, and Z, we are consuming it. So probably we'll need to.
We have to pass
a reference.
Or
not. Okay, no, that's as expected.
Yeah.
Cool.
Okay.
So basically.
Yeah, because we are not we don't need to consume it because.
Yep. Let's see though if we're not doing anything that mutates the original array, so that should be fine.
You just generate a new scanner.
Now here, of course, we need to change all these guys. Which is
you can do a multicursor because you are not seeing them as aligned, but they are aligned. Yeah, there. Done. Another one there. Yeah. Oop la la.
Multi-cursors. Amazing. Okay, now clip is going crazy because so much stuff that we are not using, but all of this stuff is done. So we
Take it easy,
could
Clippy.
technically remove all of that. Now, what are we doing here?
Now, we are flipping the Z axis.
Mm-hmm.
So we are doing the same 6 ads. Okay, you don't have the first one, but you can copy it from line 40. We are doing the same 6 push, but with Z inverted. So I was inverting Z and doing the 6 pushes.
So
I was
we can do a
inverting
new
Z,
let Z, right?
Yeah, I was inverting Z, mutating Z. Here, what you do in Rust, you create a new vector Z that will shadow the old one. You know what? Makes sense.
We
Maybe
could also mutate.
Reverse, not reverse, is changing the sign to the integers. Is a map in the end.
Yeah.
You can create a function to do that because we have to do this on top of multiple axes multiple times. So you could create an utility function that is just doing a map. Is inverse more than rev because it's not changing the sort order, it's changing the sign.
So
takes a vector of E32 and gives back
a new one.
Yeah.
And basically what it does, let's do a reference again.
Yeah.
What it does, it lists dot either map, and then we take X and we return minus X.
Minus X.
Dot collect.
Nothing more, nothing less. So yes, we write a little bit less. So now we could even do this in line at this point.
Or we could just do, just for being explicit,
yeah.
Inv Z.
In Z, yeah, equal to inverse of Z. I never remember if Rust is a camel case or snake case with a variable name.
In reality, it should complain. It should be like this, to be honest.
Okay.
It's more Pythonic in that sense. Okay, so now we basically need to do the same stuff.
Now people will kill me, but I just think that snake case is more readable than camel case. You are free to bar me in
I come
in the public square, but yeah, I just think
cool. So let's copy all of this.
And
another multi-cursor madness. And we do scanners with 2 ends.
And 1
push. And we need to pass scanners from row coordinates. And now we close all of this, but we need to use inv Z.
Yeah, we don't have to use Z, but inv Z.
Oh, and also all the... Wait, let me do the thingy first. You happy now? And now every Z
must be inv Z. One day you have to tell me and teach me how to do that with the multi-cursor, but not now.
Okay, now here you were inverting Z again, which we don't need to do it because
we don't need to do because we kept Z. So yeah, but we have to invert Y.
Perfect. Okay. So actually, you know what? No, is it okay if we have X and inv X?
Yeah, Y and inv Y. Yeah, we need all 3 of them. So feel free to create them as soon as we create the. Just put down the right variables, otherwise it's a mess.
Yep. Will be funny to figure out how to test
the debugging, if you miss Z with X, yeah, the debugging will be beautiful.
Okay, let's remove all of this because technically it's done. Okay. Now what we are doing is
the same again, but with inverted, only with inverted Y.
Inverting Y only. Yeah. This is Z only.
Yeah.
And basically what we do is all of this stuff. And again, madness. So scanners.push, scanner from complete. Yeah, thank you. And now ampersand, semicolon. And now we replace all the Y's with inv Y. This is super tedious. I think people are going to
Yeah,
kill
we
us.
fall asleep
But,
on the keyboard.
yeah, wgaffa is agreeing with snake case.
Yay. Now this is inverted X and inverted Z and inverted Y.
Okay, so now we copy all of this again. And we do all of this. I'm going to get faster.
Yeah.
This is when I do mistakes.
You could copy and paste this prefix. I think we will use it a lot. But... Also, you can make a copy of this in the clipboard with all the copy this slice in your clipboard.
Is it always the same ordering here?
Oh yeah, it's always changing. In the
Okay,
same
then yeah, you're right. So here we need to invert Z and Y, right?
But copy the save this. Copy this like it is now. Those 6 lines. Copy them.
Cool.
Okay, just for
Now,
later use. This is inverted Y and Z. Yes.
now Z as well. Perfect. So this one is also done.
Yeah. Now we have inverted X, Z, and Y, all 3 of them.
What happened?
Where are you going?
I don't know. I think I jumped somehow. Right. Okay, now copy paste, and we just need to change here all of them.
Everything
basically.
to inverted, yeah. All of them to the inverted version.
I'm just gonna do the thingy. Oh no.
No, you failed.
Miserably. Okay, this one was probably the easiest.
Yeah. Okay, next
And
one
now
next one is
I
on
can delete all
inverted-
of this, right?
Yes. Next one is on inverted X and Y.
Who's complaining about scanners?
Why it becomes scanner?
Okay. Maybe when I jumped up, I deleted that S.
Ah, okay.
Cool. So at this point,
Your
we
clipboard
have
is still
this, and we just need to invert X
and
and Y.
Yeah. This is tedious, but if you make a mistake here, debugging this will be a
A
nightmare.
disaster. Yeah.
Yeah.
Okay. Here, what are we inverting? You are reverting Z
here
and
So
Y.
here we have inverted X and Z. We have inverted X and Z. Yeah, it's a nightmare. This exercise was a nightmare.
Okay, so in this one, we need to invert X and Z. It wasn't Advent of Code, it was Nightmare Before Christmas.
Nightmare Before Christmas, exactly.
Almost there, last one.
And the last one is only inverted X, I think.
Which we haven't done yet, right?
No, we haven't done yet. You can check in the comments, but I think... and this is the last. Nice.
Perfect. So we have, assuming that this was, did you have any test for this one?
No, we can make a test after we implement the matches, because there are examples in the README, and we can implement tests on top of those examples. Now we complain about not using stuff.
I'm just wondering if it's
building
worth doing another file, but let's keep going for now, and then when it becomes too painful, we'll start to move everything in another file.
Yeah. Now, I think the stuff to do is implementing the function that is trying to match two given scanners.
We had other helpers. We had the sum tree and
is used by the matches. I don't know if we can do that in a simpler way.
We can implement it in the point, right?
Yeah, it's a point plus another point and a point less another point. Yes.
We can actually implement the addition for the point type.
The plus operator and the minus operator. Okay, cool. I never did that, so let's try.
Let's check out the documentation because I don't remember. There is a trait. I think it's the op.add, something like that. Rust op add. Let's see if my memory is good. std ops. Yeah, pub trait add, and then you specify this. Oh, you look at this example.
Oh,
very close to what we need.
Copy paste.
Yeah, let's copy paste all of this.
Yeah, there is also an example for the diff, for the minus, or well, we can do that. Copy paste
So
for the
let's
win.
put it here. Actually, let's implement add for point 3D. We'll need to import the add. So this guy.
Ah, okay. And there will look if he's auto suggesting you also. Well.
Yeah, we should really do another file because with the scrolling speed, this is very unmanageable. So here, what we want to do, it returns a self with other x, other y, z.
Yeah, but in our case,
self.
it's not a 0, 1, and 2.
Oh, you're right. You're right.
Because we didn't
0.
name it the coordinates. We just went positional. I mean,
Totally right. Good point.
not a big problem. I mean, in the end, for our example, having them called x, y, z is even worse.
And actually, here is literally this. Like, we don't even have to
name. Okay,
cool. It's happy.
Yeah.
And similarly, we need to do implement diff.
It's called a diff
or sub. Let's see.
Try to
Ops add assign div neg. There is also negative. We could have used that one.
Yeah.
Sub.
Yeah, sub. Let's see. Yes.
Point, pretty much.
Yeah.
Okay,
Yeah.
cool.
Oh, but let's not copy that. Let's copy add. I mean,
let's copy this one, and just rename it to sub, and then we just need to invert the
sign. Yeah. And import sub because I think we have to import it.
Sub. Cool. Okay, because I'm sick of scrolling, I'm already gonna do this. Point 3D. rs. And
you move everything.
Mod point 3D. So mod basically is like take everything that's in this file and assume it's in this other file. And now we can cut this one. Here.
Do you want also to do a scanners one?
Yeah, I will definitely do that.
Okay, cool.
There is a lot of stuff in here. Scanner for coordinates.
My point is after the scanner, is below. Scroll.
So there. We want to copy all of that for sure.
Mm-hmm.
Cool. And this needs to be public, I think, to be able to be used on the other side. And now basically what we want to do is use point
scanner
3D.
Okay.
So this is basically using everything as if it was in this file. So that should make everything work.
So mod, what is used for? It's not
mod is like consider this file as part of this code,
and then why do you use? Why do you use?
Otherwise, you need to say point 3D is like a namespace, column, point 3D. Okay. So this is like moving that namespace to the top level.
Merging
implicitly,
the namespace.
Yeah. Implicitly, a file is like creating a namespace. That's kind of the bottom line.
Yeah, is to avoid to do points 3D, colon, everything, everywhere. Yeah, it would be annoying.
Okay, so we'll need to do again mod scanner first.
And use scanner star.
Mod scanner. Use scanner star.
There are conventions in these import orders in Rust.
I'm not sure. I'm just gonna trust whatever Clippy likes.
Scanner, you wrote scanners.rs and you called that scanner. Do you want it with S or without S?
Did I? Without S, because it's like one object.
The file is without. Okay, sorry.
Yeah. And I imported it correctly.
Yeah, without. Okay, sorry.
So let's.
My eyesight is bad.
Copy paste all of this. Oh my god! Yeah, so much stuff here. At the top of the screen, if you have a good eyesight, you can see how my CPU is being throttled right now. Okay, parse input is the only thing we want to leave here, basically.
Is that 77 degrees that now is yellow?
Yeah, it's like 56% is the actual CPU I'm using, and this is the temperature of the CPU.
Okay. But well, when you live in out country, it's normal. Come on.
Yeah, like Ireland.
Yeah.
Okay, so here we want to do use create, I think, is the point 3D. Does it work? Oh yeah, point 3D, did we make it public? It is public, so what doesn't like it?
From the main file, you are doing use, and from here, you're doing create.
So wgaf is saying, I usually have std on top, then create specific after that. And last I have use for the local create specific stuff. Okay, that's a good suggestion. We can probably copy that. So basically what I'm saying is the lib is kind of the entry point for a library. This is like the main file. So generally what you do when you want to break down this main into multiple files, you do mod for every single file, and then you use whatever you want from those files. But then if between these libraries, these like mini internal libraries, you want to import each other file, like here in Scanner, we want to import point3D. One thing that I figured out, but I don't know if it's a good approach, is to use create, which basically is like take the point3D from the top level.
Okay.
Now, why it doesn't work? I think because here we'll need to do pub and pub to basically export them, make them available. Yeah, now it's up here.
Because you're not importing point3D from the point3D library. You're importing point3D from the librs file, in theory.
I think so. Cannot initialize a tuple structure which contains private fields. Oh, right.
You have to make the fields public. Public iter2. But yes, otherwise you have to create a constructor.
Okay, and this makes so maybe I didn't have to make them public. To make them public here, I mean.
Try to remove it, and we see.
And Scanner also needs to be pub, that's for sure.
Rust is full of pub, like Ireland.
Okay, we'll get there. Sorry for the pain. So what's going on here? Is this good? No. From string, we need to import it. So give me the auto import, please. And what else is missing here? Why doesn't like add? It's not a member.
It's not called add.
Oh yeah, of course, of course. This has been always a mistake. We just never realized.
Yeah, copy and paste. What can go wrong?
Cool. So this is up. Is this one up here? It's up. And now I think we might need to make these functions public as well. Let's see what happens.
Rotation, probably yes, because we want to call it. Inverse and the other one not, because they are just used for rotation, so they can stay private or
okay,
protected.
Perfect.
Now we have to implement the match of two scanners, and that can go public inside the scanner implementation, right?
Or now why here is an API? We need to probably make public them as well.
That is not a constructor.
Oh, this one is not needed anymore. No, this is not a constructor. This is just
okay. So yes,
manually.
we have to make them public. Yeah, if we instance it manually and not with a new, we have to make public probably.
We could do a constructor, but we are lazy right now.
Yeah, lazy.
Okay, sounds good. So what's next?
The match.
The match, which is one of the functions here in the helpers. This
last
one matches,
function.
Right?
Then when we have that one, we can start writing a test.
So this one should it go in the scanner file, right? Because it's like
comparing two scanners. We can have it inside the implementation, taking self and another scanner.
Yes. What is the possible result?
Possible result here is let me see.
Because you're returning a tuple of either none.
I'm returning another beacons list, but shifted compared to the scanner 0 that is in this function. So I'm returning what is in scanner 1, but translated to go in the to use scanner 0 as the 00. So to go in the to translate all the coordinates, because we have to do this job of translating the coordinates. And I'm returning the position of the scanner for scanner 1. Do you remember that every scanner has a scanner position, but we don't know that position? I'm returning also the scanner position because it's needed for part 2.
Okay, fair enough.
So I'm returning, given self and another scanner, I'm returning the other scanner that is, if it is matching, otherwise I'm returning no, so it's an optional, this one, rotated in the correct way, and the position of the scanner point. The probe, how it's called. I don't remember if it's called the probe, because there are beacons and probes, so this is the probe. Yeah.
No, it's beacons and scanners.
Okay, I don't remember. In any case, that one. And otherwise, I'm returning none. I'm returning 2 of them because to keep the signature of the return value consistent instead of returning a single known. Because in my Python code, I was doing an unpack directly, and unpacking a known in 2 is not possible.
Okay, so basically, let's try to make this somewhat idiomatic to Rust. So here we can implement something like publics fn matches.
Yeah.
And it needs to match another scanner.
It takes self.
Self, you're right.
As a reference, because and even another scanner as a reference. Let me think. Yes, because we are returning a new scanner because we have to translate. So we take another scanner as a reference. And we return.
This guy returns a tuple.
A scanner. No, it returns a scanner because we have the coordinate of the scanner inside the scanner structure, if I don't remember.
But it can be optional.
Yeah, it can be optional because because it cannot match. So we have to return an own. If you go in the scanner class, there must be beacons and also
in the scanner class.
In the definition of the scanner struct, sorry.
Position and beacon.
Yeah. I'm returning beacon and position in Python. I was just returning them.
Oh, okay, fair enough. Yeah. And beacon can be rotated in different ways.
Yeah, we have to translate based on what we found out. Yeah.
Okay, so let me copy paste the Python code first. So what we were doing here is def matches for I and S1, which for you was...
they are all the possible rotations of the... Why am I keeping I1? I think I don't use I1, so I think you can avoid the enumeration. Yeah. Probably in the first solution that I had, I was doing something with it, but this is for all the rotation in the rotations of the scanner, but not the scanner, not self of the second scanner. So scanner dot for rotations in scanner dot
self.
Not self scanner. Self is not moving. It's a scanner that is the one. Yeah.
Okay.
I keep,
this is the first line, right? Then you keep CNT. What is it? Is a counter?
Is a counter.
Oh, you want to count how many points are matching, right? Because we need to match at least 12. Was that the thing?
Yeah, that is a counter that keep tracks of. This is hard to explain with words. How many points are at the same distance?
Yeah, we're basically trying to overlap different things, right? We just try different rotations. We see how many points overlap. If there are at least 12, we are assuming we found a matching rotation, right?
Yeah. I'm using the distance as key of this map, and the value of this map is the counter value. So CNT is a map between a 3D point and an integer. Can we use the 3D point as key?
I think so. We just need to make it hashable, which I think it should be derivable.
Yeah, it's a tuple.
Hash map, right?
Angular brackets, and this is between point 3D is the key.
The value is a U size, right?
It's a U size because it's a counter, yeah, so it's only positive. Starts from 0 and only goes up.
Let's see if this is going to work. I think that it's going to complain about a few things. The point3d doesn't have hash, and that it is not deriving default. So we might need to do a few things. We need to do default and EQ and partial EQ and then hash, I think, are all the ones we need. Let's see if that's working. Okay, seems happy. No? We're too fast.
No.
And declare, how do you do default? Is it the opposite? Is default? I never remember.
Seems so.
Okay. And hash map.
We have to import it. Do we have to import hash map?
It should have done it. I mean, it gave me the suggestion and I hit enter. Probably it didn't. Cool. Okay, so hopefully now it's active. Okay, now what do we do with matching? So this is basically this line. Now what do we do for every single point in scanner?
So for every point in self beacons.
In self beacons,
beacon. Dot iter. You have to do all...
I think you can do it because it's a back.
no,
when you do for in, it checks if it's iterable cost dot iter.
Yeah. I'm calling 1.0 and the other 0.1 because now we have to do for every point in scanner's beacon. So we have to keep them apart.
4.1 in scanner dot.
Sorry, it's not in scanner. It's in the rotated version that you call it the rotation.
You're right. Let's call it
rotation. I think we have the ads starting, Luciano.
Should we wait then?
Yeah, I see on Twitch the ads. So people in the chat, if you are seeing ads, you will not listen to us. But if you are seeing us and not, okay, seems to be fine. No more ads. People in the chat
telling me add in progress. 40 seconds.
Okay, they're still in progress. Cool. Let's wait. Do you want to chat about cats? My cat was running around before, so yeah.
Everything we say is going to be on YouTube anyway,
so we can talk about cats. YouTube is for cats.
Exactly.
See, have you seen?
Let's see.
The internet is for cats. The internet is for cats. Remember to use rotated.
I think we should be back. Sorry for everyone. We didn't realize that we were having ads. Now we should be back. So what we were doing is basically keep writing this matches function. And basically what we are doing, we created a hash map for all the points that are matching. Then what we are doing, we're trying to compare every single point from the original scanner, so the current scanner, with the one we are currently comparing to. And of course, we need to do that for every rotation. So this is ugly because we have 3 nested for loops. Yeah. But we basically need to compare every point for one set, from one set with every other point in the other set, but also all the possible rotations in that second set. So that's why we have 3 nested loops, right? And for every one of them,
we are computing
for every rotation, we are calculating the number of them that overlap. And if we find more than 12 that overlap, then we found a matching rotation.
Yeah.
Otherwise, we keep going.
Yeah, we keep trying. Now here we have to compute the difference between the 2 points, having implemented the minus operation, the sub. I think we can just do 0.0 minus 0.1.
Yes, 0.0 minus 0.1.
This one will be the key of our hash map that we created in line 122.
So what do we call it?
You can call it key, is what is used for, is distance.
Let's call it
it's
key.
Not even distance, it's the difference, call it key.
Yeah, I mean, it can be kind of a distance between the 2 points, right?
Yeah, in all the 3 points, because we have to keep all of them. So now, matching of key plus equal 1, but if it's not there, we have to go with a 0. So it's matching that. We used that to have the default values for missing keys. It was, oh my God, I don't remember.
But we have an amazing suggestion in the chat. Can we see your cat, Robert?
Just a second,
right.
I have to
type it. Reflection. Yeah, we should do like a reward type of thing that you can claim. Get Roberto's cat on the stream.
I'm waking him up, so now it will bother me for half an hour because we have Mezzo here. He only has 1 eye. He's off by 1. Are you happy?
But the other one works really well.
I think the other one works. He's already something. He's 15 years old. He's a little bit old. Okay, stai lì. Sorry, I have to talk with him in Italian, otherwise he's not understanding.
Yeah, mezzo also means half in Italian. So
his real name would be Grim, like the Grim Reaper. Then, then we saw him growing up, being half of his sister, and so it's Mezzo. And also Mezzo because he's not super smart, so we are joking saying that he has also only half brain.
I think if we let him code, he's going to write better Rust than we do.
Some days ago, he tried to code on my keyboard while he was working. Luckily, he only sent messages on Slack.
Work Slack, right?
Yeah, work Slack, obviously. So,
All right. So
we have to do if you don't find this, I think there is a syntax altogether to do that. Let me try to Google that.
I think this is the syntax, if I remember correctly.
Mm-hmm.
And then we could basically do asterisk x to assign a value to that entry if it exists. Is that what we want to do?
We have to increment it if it exists.
Okay, so basically plus equal 1.
Yeah, I was looking if there was a get or default.
No, I think we can do... Oh yeah, get or default it will... Yes, that's better.
But I don't remember exactly the syntax, obviously. I'm trying to Google it, sorry. And I don't remember if he's giving you a reference.
It gives you this entry object. Okay, let me check this entry thing in the docs. Then you can do or insert. Map entry or insert, and then you use the entry. So sum doesn't make any sense. What we want to do is basically let x equal or insert. But what do we insert? Because this is going to be a point.
We insert a 0. No, this is a counter. The value is a counter, so we insert 0.
So or default is going to be 0.
Yeah.
And then we do...
Yeah, it's a reference to a mutable usize. In any case, we do x plus 1.
I think that should work. Let's see. It's complaining about a lot of stuff.
Perfect.
Yeah, we found the docs. Thank you anyway, W Gaffa. What is W for, by the way? Is it your first name? Okay, cannot move beacon, so we don't care. We can just take a reference. And probably here is the same problem. And now here I'm sure that it's going to try to do a diff between references and in complaints. So probably we'll need to do this.
But sub can't take a reference. The implementation of our point 3D sub can't take a reference instead of
we might have to implement it explicitly, probably, or not. Seriously? Ooh, his acronym. His nickname is an acronym for who gives a flying F. Anyway, amazing. Now we know that. Cool. Okay, we cannot call you by the full
no
acronym.
Not by full name.
Keep calling you WGAF unless you have another preference. Let us know.
Yeah.
Okay. So, by the way, if in the chat you know this one, I'm not really sure what's the best approach here. If it's worth implementing the
show me the sub in the point 3D file. Is already taking a reference. Why we are not taking a reference to self and a reference to other? Because we are returning a new object in any case. Line 12 and line 20. Can't we take reference to self and reference to other?
Because I think that's the...
that's the signature of the trait.
Yeah.
So we can't
change it. But we might try to do this just to see what happens. And if anybody knows a better solution, let us know. And I think that at this point you have here a reference and a reference. Is that everything we need to do?
And then you have to return a reference.
And you have to return, in that case, a new...
Can you return a point 3D instead of a reference?
Yeah.
So you have to also change line 20? Or
Exactly, 21.
No, I mean 20, the one on the right. Yeah, that one.
Is that enough?
I'll do that also for sub, and we are done.
Okay,
makes sense.
It's just a little bit annoying that we need to do this, but anyway, sub, and this is sub, and this is minus everywhere.
WGAF was suggesting to add copy to the derive in line 6 to have the copy trait, just to have the copy abilities, but I think with this we sorted out the...
My understanding, and then correct me if I'm wrong, but my understanding is that copy is something that you should avoid as much as possible to derive, unless you are talking about like wrapper of basic types like integers, because then you are doing clone everywhere without even realizing. So as long as it's like the same size of a pointer, yeah.
You're locating memory like crazy. Okay, cool.
But this is my understanding. Maybe I'm wrong on that.
Okay, now on the other side, here is happy now to remove the stars from 0.0 and 0.1. At this point, you can do just 0.0 minus 0.1 and have a 3 point out of it.
Seems quite happy. Spoke too soon.
Yeah,
what's going on here? Cannot borrow matching, so of course this needs to be like that.
But we declared the hash map as point3D, not reference.
Oh, and this one needs to be mute as well.
Yeah. Do you need that reference? Because we declared that we want a point3D against IU sites. We have to change the type in line 122. No.
I'm not sure.
All good?
All good, I guess.
Let's try to implement the first test that was in the README at this point.
Is that the entire thing? No, wait, we didn't add
the sorry, you're right. My God.
We didn't add the most important thing.
Yeah.
So after we do all of this, still in the for loop, right? Or no, you do it outside.
No, that's outside the double for loop. Yeah, when we have our matching hash map populated. There, I'm looking if there is one counter that went above or equal to 12. So of all the values, not the keys, all the values in matching, is there a value above or equal to 12?
Why don't you do that inside the for loop?
Because I have to wait for all the possible comparisons. Yeah, I could stop before, to be honest, you are right. But probably was, I don't know.
Okay, because, let's keep it as you did, and let's put.
Yeah, we can optimize later. I'm thinking because doing that list comprehension in Python, the one in line 114, is, I don't want to say that it's expensive, but requires a little bit of time. Doing that inside the quadratic loop, yeah, could be overkill. But yes, you're right. We can do that while we go.
But you might be saving a lot of rotations, right? If you're lucky and you just find the first rotation.
You can save. I stop every rotation because we are inside the rotation loop. I could avoid a lot of differences between points. But let's do that here. Then we can move it inside and see if the tests are still green.
Yeah, I know. By the way, I'm thinking this is maybe thinking out loud and a little bit prematurely optimization, but what we did in the previous exercise with the iterator using like generators, we could be doing the same for scanner rotations.
Yeah.
And at that point, I think all of this stuff would make a lot more sense because then you are not going to even yield the additional rotations if you find a match straight away.
Yeah, in Python, I was yielding for that reason. So the first match I was finding, I'm not creating in the vector any useless rotation.
Another potential optimization here is
make it an iterator and a generator.
Use the generator crate to do this basically. Okay, so and actually I remember the generator crate was quite fast, which I was surprised. I was expecting it to be slower than the other alternatives. It was actually the second fastest. So, and not like it was very close to the top one. Anyway, so what do we want to do here? Outside the second for loop, what we want to do
line 115 basically is taking the key from the hash map that has a value 12 of above.
So we should do like a find. Basically,
yeah, it's a find. It's a find in the hash map of any key, because I don't care which one, because probably there will be only one with more than 12 in the value field.
Okay, so let's see if matching has like a find method or something.
Seems not.
There is an iter which gives you key and values.
Okay.
And then we can probably do find at that point.
Well, we can do find.
Right?
Okay.
And at this point, the predicate gets
key and value.
An X, which is probably key and value, point3D and USide. So we can do K and V. Ooh, double thingy, but whatever, doesn't matter. And what we want to check is that V is major or equal
to 12.
12, right?
Yeah.
So K doesn't even matter here.
No, K is not. It doesn't matter for the search. It matters because it's the value that we want out. But this find is giving you The pair back.
I think yes. Let's check. So let
You can do
M.
if let sum. You can do a
Let's
if
see.
let.
Yeah, we can do that, but it
Yeah, it's
gives us
giving-
both.
Perfect. But well, we just need the first one, so we just need a point
Okay.
3D there.
If let sum of something, we'll fix that in a second. So that something is actually point 3D. So what we can do is another match, and we don't care about the value, but we only care about
key.
key.
Yeah. So we match the name from above. Cool. Now,
And
this
now
means
what do you...
this means that we found a matching. So we have to return a new scanner. He's complaining. It's a double pointer to your side.
I'm wondering that I need to do a double asterisk. Is that okay? Yeah, cool. Now we have this key. What do we do with this key? You return a tuple of sum 3.
We return a scanner. We have to return our scanner. Our sum scanner. We have to return.
Okay, so we return some rotated scanner, right?
We have to return a rotated scanner, but summing to all the points in the beacons the key.
Oh yeah, because you want to change the core.
Yeah,
rotated
scanner is matching, is rotated in the right way, but can be in reality with the points here. We have to do this operation of moving the points to overlap for real, and to make them overlap for real, you have to add the key to all the points of the rotated scanner. We can create a function, I don't know. Yeah, normalize the rotated scanner, yeah.
Ice cream is here. I don't know if you can hear the music.
Yeah, a little bit.
Yeah, my microphone picks up the background
rotated
sound.
Scanner, we can add a function to the scanner to do this translation.
We could, yes.
That is move. We can call it move, because in reality we are moving all the points by another point.
Yeah, let's do that. Let's do pub fn move, which takes a mutable self.
Takes can take
and
or a mutable self or a self and giving you a new one. Oh no, let's take a mutable self, yeah, and a point, exactly. A 3D point, a point 3D.
Or do we want to return a new one? Like takes a self. Let's do that, because otherwise we'll have problems, I think. And a point 3D. And it returns a new scanner, basically.
Yeah.
So what it does is basically clones the first one.
But well, why do we clone? We create new objects. Don't clone. I don't think we need to clone.
Oh yeah, we can create a new array with a map. We already
I think we can do everything in one line. We can return directly here a scanner.
Oh, sorry, I totally missed the chat. WGAFA was giving us a lot of suggestions regarding whether it's a good idea to do copy or not. So it's saying that if the underlying type is copyable, Rust will do cheap copies. In this case, the types of pointed 3D is an I32, so it will be cheap to copy, is my understanding. But it's not just one I32, it's 3 I32, right?
It's a tuple, but well, still cheap probably. But in any case, we went with references in the end.
Okay. Yeah, it's something to review anyway, so it's a good suggestion. Sorry, so we were saying we can do let scanners.
But we can directly return a scanner. No let. Scanner, open curly bracket.
Oh, I see what you mean. Yeah, super concise.
The position is the point. The position is the point.
Ooh, good. Okay.
And the beacons are.
Wait. We probably want to get a reference, so we call this one.
Okay.
So we have a ownership of the one, and the beacons. And this needs to be some. Wait, because this is an option.
Okay.
And this is self.beacons
map.
And then we have a point p, and we return p plus point. Now probably, because we implemented reference, all of that works or not? Because this is probably a reference to a point. No.
Now let's see.
Oh no! Wait, Peter. That's what's missing.
Okay, sorry.
And then probably collect as well.
I always forget to iter on top of stuff. For me,
and collect.
A vector is iterable. Yes, it's a vector. Obviously, it's iterable.
Okay, is it happy? It is happy. This lag is pretty horrendous. Sorry to everyone watching.
I was in a new laptop.
Okay, so normalized scanner is basically rotated scanner dot moved
of our key.
Of our key.
A reference to the key. Oh, it's already a reference. No, it's already a reference, so it's perfect. Types already match.
And now we return some normalized scanner, which doesn't have to be mute anymore.
No. I think we can try to implement the test that it was from the README, if he's happy, if everything here is...
Should we do the test in this module, in the scanner module, right? Because...
Let me think. Yes, I think it makes sense to make the test here.
So we do tests, and we do mod tests, and then test matching.
Yeah. If you go in the README, there are examples in the README about, for example, it says scanner 0 and scanner 1 on the example match on this point.
So if we go in the README, let's check that.
Yeah. If you scroll, this example that has 5 or 4 scanners. At one point, if you go a little bit down below, it says scanner 0 and 1 overlap. And if you stop there, line 281. Line 281.
This one?
Yeah. Because of this, the scanner 1 must be a 68 minus 1246 minus 43. That 3 numbers will be in the position of the scanner that comes out of the match function. If we did everything correctly. And we compare scanner 0 and scanner 1.
Okay, so what we want to do is... the problem is that we have a parsing function in the lib, I think.
But we didn't move the parsing in the...
We can move all of this and rename it to scanners from string.
Yeah, the parsing for the scanner has a sense to be the scanner.
I think so.
We just need to parse 2 of them, not...
Public. And this one is pretty much the same.
Yeah, no, we can keep
and
the
here
same.
What we want to do is scanners from input. And now here what we want to do in the test is to take, use super one.
Super what?
Now here
okay.
We do let data equal for input, let's call it. And we take from the README only the first 2, right?
Yeah, scroll above. Yeah, take only the first 2.
These 2, scanner 0 and 1.
Yeah. There.
Cool. Now I think there is a way in Rust to do this kind of thing that is going to automatically fix the indentation, but I don't remember.
Oh, yeah.
Manually do this.
Yeah. Multi-line strings ignoring the indentation.
There is a way, like I think it's like hashtag or something like that, but I can never remember.
Don't remember the syntax.
Let's be lazy for now. So now what we're going to do is let mute scanners. Actually, it doesn't have to be mute.
Okay.
And we want to do
scanners from input. From input.
And this is the reference.
Yeah. Now these must be 2 elements, this vector. And if we do the first element dot matches the second element, we must have back a scanner object.
Okay, so let first is equal to scanners 0. Let second 1. And now what we want to do is let matching is equal to first matches.
Can you scroll
second.
A little bit? Okay, yeah. That will give you an optional scanner that we know that must be something. So if it comes back unknown, it's wrong. Yeah, it should match because the README tells us that it should match. That matching position must be the one written in the README. Then I will not assert on top of all the points because madness, but we can assert that matching position
dot position, yeah,
is equal to what was the 3 points in the README.
Point 3D of these 3 points that we're going to get from there. It was
281, line 281.
281, there you go.
68, yeah, those 3.
So, but
will
why
it
does
work?
it like this?
No.
Do we need to implement the equality for points? I thought we did. We have equality and partial equality, so what's missing?
What was complaining? Position is public, yeah.
Come on, give me the actual error. Expected. Oh, no, wait.
Position is optional.
Yeah, okay.
Position is optional.
Expect.
But you can say some point.
Oh yeah,
well,
right. we know for sure.
Yeah, or you can say some point 3D on the right or not. On the right. On the right instead of point 3D. Some point 3D.
You need to use matches. I think if you want to do that, you can do assert and then matches and then sum this guy and that. I think this might work then. Tests is this called? Oh yeah, this needs to be called test singular, I think. Or not. Wait, I can never remember how to write tests.
CFG tests.
CFG tests. Okay, fair enough. And then the name is tests. Use super and test. Okay, fair enough. So now it should be correct. Are we brave enough to try it? Oh, thank you for the following. That Disco. That's a great name. How are you today? Okay, running the tests. We should have done a poll to see how many people believe that this is going to run.
I think you still have time, considering the speed of your machine, to do a poll. In the 5 minutes, it will compile and everything.
Oh no, we already have another prediction running, so we cannot do it.
Oh, no.
Yeah, expected option found struct point 3D. Oh, right. Yeah, because if you want to use matches, you're not destructuring. You need to match apple with apples, right? So we need to put some around this one as well. Or not. I'm not so sure why.
Or we can unwrap if it's not working. We do an assert equal with an unwrap of position because... Try.
Yeah, fair enough. But I mean, this is still... Expected enum. Found struct.
Do you have to write options?
Let's just do it like dumb people as we are.
Because it's already failing in line 235 if it's not unwrappable, right?
Exactly.
So now
that should do it. Should it? Cannot move a scanner. All right. So you want to take a reference. And now second doesn't have to be a reference. Is it? Come on,
Cargo Clippy is there running and sweating 78 degrees. There are those turbo fans to apply to the laptop to put more air inside, but
okay, fair enough. Okay, run the test. Come on, stop scrolling. Run this test.
If he's happy with the types now.
It's compiling. Good sign. Polling while compiling, yes. Hopefully we don't have like endless loops there.
Okay, it's okay.
It's okay, yeah. Test result okay. Cool. Wow. I didn't expect that.
Commit everything immediately.
Yeah, let's do a
If
commit.
you want to add even the second,
we didn't complete the part 1 yet, right?
no,
Should
no,
we
this is
complete?
Hmm?
Should we complete part 1 first?
Is not commit because that's are green, so commit in any case, even without part 1 completed, this is working first try, so it. I like the commit.
For matching scanners.
Yeah, part 1 is not terribly complicated, but is a bunch of code, I think. So if do we want to wrap up it here for today? It's already an hour and a half
Let me
that we are
just
streaming.
remove
So
this one as well. So I don't know if anyone participated in the prediction, but the prediction was like, are we going to finish this today? And we got close, but no.
No.
So this is our prediction.
Because now we have the 30 staff scanners. We have to start with scanner 0, match against all the other scanners, add to the list of the scanners the one that is matching, then going on, taking the 2 scanners that are matching, test them against all the scanners that are not matching yet, and adding them and looping like this until we run out of scanners that we don't know where to put. At that point, we will have all the scanners. We have to make a set with all the beacons of all the scanners and count how many elements we have in this set. But it's a little bit of code, I think. What do you think?
Should we just do this test, moving this one here, and see if our test is
right.
great?
You're right. Yeah.
Let's just do this one last thing for today, and then we'll wrap up.
Yeah, you are super right. I think it will work. Then if we want to know performance-wise, means it depends on the find of on the performances of the find.
Compiling. We need a song for compiling. Oh my God, blocking.
Blocking? I never saw that message.
It worked the first time. The tradition says you have to watch the test fail, or else a demon could be hiding in the test. Probably it is hiding. Yeah, and this one worked for the first time as well. So 2 demons. Yeah.
And I think we can even simplify and make it faster now that I think about it. If we want to try, we always have the git commit, right? Now
simplify
go back
and make it faster. Where?
Yeah. Go there. Now we already have X, and we know that X could be 12 or more, and we already have it. Why we have to check all the possible keys? If this is the first key that goes above 12 or to 12 is the right key. So we can just do if X greater or equal to 12 and then return. And we already have also the key computed.
Oh, you mean here, right?
Without line 145, 141, that now is 143.
Yeah, we can just do if X
greater or equal 12. I don't know how many stars do you have to put in front of X to do that.
Good point. No? Probably 1.
And then
yeah, we need 1 because this is an entry, so we need to reference the entry to get the value. Yeah.
The body is the same. The body is the same of the other if.
Because key is still called key. Yes.
Yeah, it's still called key. You can comment the other.
Expected point 3D but found. Okay,
we
just need to make a reference.
Yeah.
So we can comment this one out.
Yeah. In theory, this must be faster and working because we are not doing the find at all.
Let's see if we get 3 demons. Compiling.
There is a demon in there.
Blocking. Oh, didn't work. Value borrowed here after move. Where do we move?
When we get X, we are destroying a key. In 138, when we do the lookup in the hash map. 138, we do the lookup in the hash map.
All right.
Can't we do that by reference?
So what if we do a reference there?
Yeah, because in the end, they don't care exactly. I don't want to destroy the key.
Consider removing the borrow.
Yeah, but we need.
So
do we need to declare in 134 the hash map as a reference to pointer D to use size? Try.
Where? In line 137?
134. Add the reference in front of pointer D.
Okay. Okay. That's a good point. Makes sense now. Now I'm realizing what you mean. So this key does not live long enough. Oh, of course. That's a problem, yeah.
Because we are creating it inside the loop and the hash map is outside of the loops.
Yeah, so we cannot do this.
Okay. And how can we do the entry without destroying the key?
We need to do .clone here, which sucks, but whatever.
I don't get why you have to destroy the key to get the value from an hash map, but okay, clone is fine.
If anyone knows a better idea, let us know, because clone doesn't make me too happy, but whatever.
Yeah, try to see if it works, because it could be that you removed the commented code without testing if
We
it's
can
working.
Command Z. We also
Yeah,
have
yeah,
Git.
but
Compiling. Maybe next week I will have another laptop which will be faster. So hopefully the pain is gonna end.
works, and this is probably faster than doing the find at every loop. So it's just checking X.
Nice. Okay, so I'll
Yeah,
do
that
another
clone,
commit after the.
leave it to do in line 138 with written. Try to remove this clone. Find a way to do this without the clone. Because it doesn't make terribly sense that you have to destroy the key to access an hash map.
I agree. I really agree. I was actually expecting that entry was.
There is a comment that say, I think raw entry nightly method is supposed to solve this.
Okay, silence. That's interesting thing. But
an overlay with this message. Yeah, I think raw entry nightly method is supposed to solve this. Nice. Okay.
That's really good to know. I mean, not that we are using nightly for our solutions, but yeah. Okay, we'll test this probably next time.
Do we want to wrap up at this point? That tests are green. We refactored something. It's already 1 hour and a half.
Yes. Okay. Let's switch to the chat.
Done.
And I'm gonna prepare the raid. So basically, that's it for today. Stay tuned for the next episode, which most likely is going to be next Monday, 6 p.m. Irish time, which should be 5 p.m. GMT, but I'm not.
Yeah, now we are plus
sure.
one. Yeah, we are plus one compared to UTC at the moment.
So yeah, what we are going to do next time is just trying to finish this exercise. And then if we have more time, we're going to continue with day 20 of Advent Upfront. Meanwhile, remember that all our code is online. We have a repository. Feel free to send us PRs or suggestions or comments, anything that you think it might be useful to be improved or to just try different solutions. We also have a benchmark folder. So if you think that certain solutions might be faster, we can also have both of them and then benchmark them. This is something we have done in other exercises. And other than that, if you're watching this from YouTube, make sure to follow us on Twitch and check out the live stream next time. Or if you're following this on Twitch and you want to see the previous recording, make sure to check out the YouTube channel. And with that being said, thank you very, very much for being with us. And we are going to do a raid to another software and game development channel. Ooh, and I see that there is a dog streaming, so that might be fun.
We had the cat, now we go to a dog.
See you next time. Bye-bye.